Welcome to the webinar training series for the Equals Pre-Algebra and Pre-Geometry Mathematics curriculum. In this webinar, participants will be provided with information regarding lesson prep and lesson components for the Pre-Algebra and Pre-Geometry curriculum. If you have any questions, you can contact the curriculum team by email at curriculum@ablenetinc.com. Please feel free to contact us for additional support or follow-up questions. Remember that implementing a new curriculum will take time, and one of the most important steps to being successful is to know what materials you have and how to organize them. Let's get started. We will begin by looking at a way to prep for an entire section of lessons. Having a dedicated space where you can store your manipulatives and where you plan to teach math will drastically reduce prep time, as well as make it easy for you to swap out materials during a lesson if needed. Once you've completed organizing your kit, you should place all of your materials, as well as any classroom materials needed for math, in this math area as well. It is also recommended to have 2 sets of 10 folders. Each set should contain 1 folder for each of the following labels: skill drill worksheets, problem-solving worksheets, vocabulary pick symbols, lesson section pick symbols, work mats, only if you will be printing an 8.5-inch by 11-inch version for your student, I learned work mats, number notes, student tools, games and materials, and one for any teacher-made materials. This list is also found within the handouts in the members-only content. These folders will house the print materials you need for the lessons. Each set of folders should be placed in its own container. Know that you will fill one entire set of folders prior to teaching for your first lesson. While you're teaching your first section of lessons, you can begin prepping the second set of folders with the next section's materials. Place the set of folders in a file cabinet or 2 separate file containers. Whichever container you choose, be sure they are separate so you can keep those materials organized by the separate sections. Located in the members-only content are the materials lists by section. Each list shows the section at the top. The location of where to pull the print materials is listed in parentheses next to the heading. Also note, printing a work mat for each student is optional. Note that any time it is indicated to locate materials from the CD, know that those materials are now found in the members-only content in CD/revisions. Amounts listed in the materials list by section do not account for multiple students using the same materials unless indicated by the line times blank students as seen here. Moving on to student tools now. As a reminder, the student tools document is found in materials lists in the members-only content. For the first section of the curriculum, NO-A, the frames needed for this section have been attached to the materials list by section, as they are used to represent large amounts. You will continue to use these frames in subsequent lessons, so you may want to laminate these frames for durability. Below student tools will be the listed kit materials. This section is separated by print materials and manipulatives and tools. This section is separated by print materials and manipulatives and tools. Know the work mats are the same as the previous page. If there is a lesson that requires more than what is provided in the content kit, the amount will be listed in both spots on this materials list by section. The materials on this page will already be in your math area, so don't feel that you have to pull those materials ahead of time. As you come to these materials, pull them using the organization system that you have established in your math area. The final section at the bottom of this page is classroom materials. These materials are used to provide an environmental example of the math being taught. Many times, large amounts are represented using popcorn seeds or paper clips. Know that those representations are important for students to see, and if you need to make decisions about materials being appropriate for your students, be sure it is a meaningful exchange so students can still benefit from seeing those larger amounts in a concrete way. As you print the materials, remember to place them in the corresponding folder in your filing system. After you've filed those print materials into the labeled file folders, gather the necessary vocabulary cards. The vocabulary cards will be placed in the pick symbols folder in your filing system. The vocabulary cards are used as visual examples for students while problem solving, or when communicating their learning on the I Learned work mats, communication devices, and number notes. It is important to note that most of the materials in the classroom materials section are items that are typically found in a classroom or relatively easy to acquire. If an item on the list needs to be purchased, or you feel it would not be appropriate for your student, you can make a thoughtful substitution. Substitution should only be made when necessary, and should still provide students with an item that reflects the context of the lesson, as well as the size and shape of the original item. Now that you have printed and organized all of your materials, your current section of lessons should be all ready to go. While you are teaching this section of lessons, you should begin prepping the materials for the next section of lessons. When it is time to begin teaching, look at the top of the first page of the lesson. The materials you will need for both pages of the lesson will be located here. The materials list is organized by lesson part. This will be helpful as you teach each individual lesson. In every lesson, you will need to have printed worksheets and number notes, as well as vocabulary and lesson pick symbols. Be sure that if you would like to utilize the activity in sensing math, that you have the necessary materials in your classroom. Now that we have prepped for lessons, let's look at the supports and lesson structure you will find in the Pre-Algebra and Pre-Geometry curriculum. Equals Pre-Algebra and Pre-Geometry lessons include the following math process areas: problem solving, representation, communication, reasoning and proof, data analysis and probability, as well as a variety of connections between these areas. As we look through the lesson, you will see how each of these areas is embedded within the lesson activities. In every Pre-Algebra and Pre-Geometry lesson, you will see this instructional sequence: concrete, semi-concrete, and abstract. What this means is that students are taught the lesson objective in 3 ways. In a concrete way, students will use manipulatives, semi-concrete will use pick symbol representation, and abstract will typically include numerals, signs, and symbols. This is for all students and is a crucial part of every lesson. This portion of the lesson is written specific to the math objective. Once you introduce and teach the students using the concrete, semi-concrete, and abstract approach, you will invite them to solve problems using the materials and the manipulatives available to them in this lesson component. In this example, you will see that we are discussing fractions with a group of students, teaching students that 1/2 plus 1/2 equals 1 whole. I will begin this lesson by demonstrating this fraction using an English muffin, pizza, or fraction models. I will start by cutting that pizza in half in front of the students, showing them that in fact 1/2 plus 1/2 equals 1 whole. Now I will show my students this in a semi-concrete way. This time I will use picture symbols to demonstrate this relationship. I could also use a broken number line or area models. Finally, through the abstract representation, I will show that same objective using numerals and operation signs. This approach is beneficial for all students. For students who typically learn with hands-on manipulatives, seeing the semi-concrete and abstract representations benefits them because they can see what else math is all about. When they are developmentally ready to move on to the next stage, they have this background knowledge with them. For students who understand math at an abstract level, they benefit from seeing this concept taught using manipulatives. The different representations help students remember the concept better, makes a bigger impression, and deepens their understanding. Pre-algebra and pre-geometry lessons were developed with differentiation in mind and is embedded into the lessons and strategies. There are 3 different levels of differentiation to accommodate individual student strengths and needs, and teachers can easily move a student to the appropriate level as needed. This flexibility allows students to learn alongside one another regardless of their cognitive or physical abilities. Level 1 activities include hands-on concrete learning. The activities and strategies are presented using manipulatives or math tools with picture support and a limited field or workspace. This level is highly supported. This group would typically include students with significant language, motor, and/or cognitive delay. Level 2 activities offer students the opportunity to solve math problems with minimal supports within an organized framework. Students are still given concrete representations, but utilize environmental examples to strengthen their connections. Worksheets will still include picture symbol support and include a limited number of questions. Typically, students at this level have moderate disabilities and have demonstrated an understanding of math concepts. Level 3 students have demonstrated math skills and utilized the taught organizational framework when completing math tasks independently. Worksheets do not have picture support and include multiple questions on a page. These students usually have mild to moderate disabilities and have a strong understanding of the math concept being taught. This instructional strategy is located in the problem-solving and close sections of the lessons. Once you become familiar with the curriculum, you will recognize that the objective stays the same for all students and the levels of support are fluid within each lesson. Please remember, teachers choose the appropriate level of support for their students during each lesson. Students can also begin the lesson at one level and be moved to a different level during the lesson if appropriate. As you get into the pre-algebra and pre-geometry lessons, be sure that you are teaching math thoughtfully. This can be achieved by committing to the progression of lessons you find in pre-algebra and pre-geometry. The lessons are written in the same format from lesson to lesson. You want to follow the format as written in order, not picking and choosing, so students can learn and build on that learning as you move forward in the lesson. Teach the lessons in the order they are laid out within the lesson objectives. It is important that once students are placed, teach and move forward in that lesson progression. Teach for understanding. Learning how to add 3 to 4-digit numbers with Learning how to add 3 to 4-digit numbers with regrouping using an algorithm is of little use to learning math unless students also learn and understand place value. While some students tend to love the predictability of an algorithm, this does not teach them math or allow them to practice the skill outside of the classroom when a variation of that skill appears. Use opportunities in your classroom to connect what the students are learning within the lessons. Think about applying fractions, percentage, or ratios to snack opportunities or members of a group, for example. Take the time to show that numbers from a clock, ruler, or number line are from the same system of numbers. Students are now active learners of math. For some students, we need to teach what that means by giving intent to language attempts, accidental or purposeful, and to provide a means for students to touch, hold, and move manipulatives and tools. Remember that all students in general education and special education develop misconceptions about math. Be aware that this happens, and know that just because you teach it one way does not mean it was understood in that same way. An example of this is the equal sign, which, for many students, means here comes the answer, rather than one side of the equal sign is the same amount as the other side. Before we get into the lesson itself, we're going to take a moment to talk about establishing a focal point in your classroom. The math focal point is used in the classroom to display various resources such as the number notes poster, theme posters, and vocabulary cards. This is a live space meant to support students as they work through the pre-algebra and pre-geometry lessons. The focal point should be somewhere that is accessible, has plenty of space so students can add information to the focal point, and the focal point should be easy to use. This is not meant to be a hindrance to your lessons. You may wish to start with just the number notes poster and the vocabulary for the lesson, and grow as the needs of your classroom dictate. Having a focal point in the classroom gives students a reference for what they have been working on, and therefore should be created by the teacher with the students. Here's an example of what you may place in your focal point. The number notes poster. This will be updated as the lesson progresses. The theme poster for that lesson. Vocabulary cards from the lesson, as well as other materials of your choosing such as student work, concrete connections that you'll create with your students during the lesson, or anything else that will be helpful to your students. If you continually add to the focal point each day, by the time you complete the lesson with your students, you can use the information in your focal point to review what was learned. Now, we will walk through a lesson. Remember that each lesson in pre-algebra and pre-geometry is 2 pages in length. A lesson will take anywhere from 2 days and up to 2 weeks to complete. The pacing of the lesson will be determined by the needs of your students. In the pre-algebra and pre-geometry lessons, there are 4 parts to each and every lesson, and these 4 parts consist of 2 pages. All lessons are organized in the same format from section A through section Q and contain the same 4 main parts: introduce and connect, teach, problem solving, and close. Looking at the structure of the lesson plans, these are what those 2 pages look like. There are a few things to help you recognize the basic format, looking first at the top of the first page. In the upper right-hand corner of the first page, you will find the objective that is written specific to the lesson. For this lesson, the objective is student will identify 2 and 3-digit odd and even numbers. Below the objective, you will see the list of materials for the 2-page lesson, organized for different parts of the lesson. The sections are broken down into Introduce and Connect, and Teach and Problem Solving. In the upper left-hand corner of that first page, you'll find the naming convention for the lesson. This information will help you locate materials in the members-only content. The label will indicate the content area and the letter of the section, and then the lesson number. When I am looking for a worksheet, I will go to the members-only content or my prepped materials and look for NO-A-1. That refers to Numbers and Operations, Section A, Lesson 1. This coding system will be used for every lesson from Section A through Section Q. Starting with the first part of the lesson, Introduce and Connect, the 4 activities included in this part of the lesson are First Look, Vocabulary. In this lesson, the vocabulary words are odd and even, although it is important to note that not all lessons have multiple vocabulary words. After vocabulary is discussion, followed by number notes. Taking a look at the activity First Look, there are multiple layers happening in this one activity. This is where the teacher will give the students their first look at the objective or underlying concept that is related to the objective. Students have an opportunity to review familiar vocabulary or concepts in this activity so that they can apply this information to the new objective that they're working on. In this section, students have an opportunity to explore manipulatives and tools that they will be using and look for things on posters to help them support their understanding. This activity begins with working with hands-on manipulatives. In this example, the teacher is modeling how to pair 14 manipulatives while connecting the task to the vocabulary word even. One more is now added to show one counter left over or not paired. This amount can now be connected to the vocabulary word odd. After working with the manipulatives, students are then shown the theme poster to provide a real-world context. In this example, the students and teacher can discuss the odd and even amounts seen on the poster. Milk jugs are paired in even amounts, but when looking at the fruit, we can discuss how we see 2 oranges or an even amount. But if we think about the amount of oranges and tomatoes, that amount becomes odd. The next layer includes a math tool, in this case, the 10 frame. The amounts 1 through 9 are marked on the 10 frame. Using this math tool connects the idea of pairs that was shown with the manipulatives to recognizing even and odd amounts on the 10 frame. The final layer includes more of an abstract representation of the concept. In this example, odd and even numbers are shown on the number line using WorkMat 17. The next activity in Introduce and Connect is vocabulary. The vocabulary that relates and supports the concepts for the lesson is now introduced. This is done using concrete connections. A concrete connection is a physical representation of the vocabulary word. It is assembled by the student or group of students while the teacher is introducing the vocabulary word. The student will now have a tangible support to hold on to while learning about that vocabulary word. In Part C, a thoughtful discussion takes place between you and the students. They can talk about what they know about the objective and any connections that they are making to the material. It also supports activating background knowledge. In this example, I can ask students, what happens if I add 1 more to an even number? You then demonstrate by sorting your objects into 2 even piles, in this case 6 and 4, and then add 1 more to one of the piles, and the students tell what happened. You can repeat this a number of times with your students. As you are listening to what your students are saying, or telling you what they know, you will be modeling writing about math by writing their comments on the number notes poster. Remember, students are talking and writing about math through modeling. Students can contribute to talking and writing about math in a variety of ways. Students can verbally state sentences or phrases. Students can use communication devices telling you what they have learned or what they are seeing you do. You could pre-record comments on the step-by-step communicator, which is included in the Pre-Algebra and Pre-Geometry kit, or students can choose from picture symbols or objects that are placed in the pocket chart, or even laid out on the table. All of these are ways for students to talk about math. When you look ahead in this lesson to Part D, Model Number Notes, you see how Part C, Discussion, and the number notes are connected. Now looking closer at Part D, Model Number Notes, this is where you will write about what students are telling you about math. You will write in a variety of ways to reflect what they are saying. This may be taping objects or manipulatives to the number notes poster. It may be placing pictures or vocabulary cards on the poster. It may even be writing sentences or phrases on the poster. Your number notes should be meaningful to your students. It is important to recognize and acknowledge what students are telling you. By writing it down, you are validating what that student is saying. You are telling students that what they are saying is important and relevant to the discussion. You are also helping strengthen the connection between verbal and written communication. Here's an example of what a blank Level 3 number notes page looks like. Blank copies can be found in the members-only content in the student tools. You may also use your own pages or blank notebooks for math journaling. Students follow the teacher's model and write the vocabulary word, as well as write what they have learned and how they solve the problems. Again, writing should be thought of in the broadest sense. If a student does not write in a typical way, know that drawings, pic symbols, and manipulatives are all acceptable ways to write on the number notes poster. You can look to the Action Dictionary for more ways to support your students with writing. The next part of the lesson is Teach. This is the component where you will find the CSA, or the concrete, semi-concrete, and abstract representational sequence. During the concrete, semi-concrete, and abstract representational sequence, the lesson objective is demonstrated in 3 ways for all students. Teachers model each representation to connect what students have learned to direct instruction of the lesson objective during this sequence. In concrete, the teacher shows objects and manipulatives. In semi-concrete, pic symbols, drawings, or specific tools are used. In abstract, the teacher uses numbers and operation signs and symbols. After direct modeling of all 3 representations, students will choose one or more representations to try out themselves as a way to strengthen understanding of that lesson objective. In this example, the concrete representation shows odd and even amounts with pennies to show odd and even groups. The semi-concrete example uses 10 frames and a hundreds chart cut apart by rows to show a number line to demonstrate the same concept as shown during concrete. As the numbers get larger, the filled 10 frames support the visual representation and pattern when looking at the ones placed to identify if the amount is odd or even. Finally, at the abstract level, you will look at the place value of a number, circling the ones place to show the odd and even numbers. It is important to note that you are demonstrating each representation to all of the students, at least twice, and then giving the students an opportunity to try each CSA activity. At this point, a student may choose to explore the concrete or semi-concrete activity because it is more meaningful to them or their learning style. This is fine, but it is still important for all students to see each representation. After the teach portion of the lesson, students have the opportunity to complete skill drill worksheets. We know that there are some students who do not typically complete worksheets. It is important to remember that recording an answer to a problem is part of the learning process. It is always recommended to use what is already successful for your students when completing worksheets outside of math time. Apply those strategies as students complete the skill drill worksheets as well. Some successful strategies could be taping the worksheet down to the table or a lap tray, placing the worksheet in a sheet protector on a slant board, cutting the worksheet into smaller sections or placing the sections in the pocket chart, or you could use the worksheet as a guide and present manipulatives to the student as an alternative, and then bring the worksheet back and record the answer using hand-under-hand assistance. You will notice that the worksheets are leveled to support differentiation for students. At level 1, there will be a high level of support with picture symbols and only 2 problems. Level 2 worksheets will continue to have picture symbol supports with more problems on the page. And at level 3, the problems will increase in difficulty and there will be less supports for the student. The second page of the lesson begins with a sensing math activity, then moves into problem solving, and finally the close portion of the lesson. Looking at the first activity on the second page, Sensing Math comes after the CSA part of the Teach lesson component. It is still considered part of the Teach portion of the lesson, but the unique thing about Sensing Math is that it can really take place at any time during the lesson and can be repeated as often as the teacher feels necessary. This is also an appropriate activity for the paraprofessional to conduct if the teacher chooses. The Sensing Math activity is an opportunity for students to explore the math concept or objective through a sensory activity. In this example, you have a tactile activity exploring odd and even numbers. You can use blank 10 frames and fasten small objects or manipulatives to the 10 frames. Place the 10 frames in a bag, and students feel the cards to determine if the amount is odd or even. This is a tactile way for students to explore this objective and make a connection. If this activity does not meet the needs of your group, this portion of the lesson could also be optional. However, most students say that this is their favorite part of the lesson because they are exploring or completing a fun hands-on activity. The next part of the lesson is problem solving. There are 3 activities within problem solving: demo, solve it, and try more. During demo, the teacher reads and solves a similar problem using manipulatives used during the CSA activity, as well as other manipulatives and pick symbols to model how an experienced math learner solves a problem related to the objective. Let's look at an example from the lesson. In this example, Cindy wants to know if she has an odd or even amount of candies. The problem states that she has 23 pieces. As a model, you will first show students how to solve a problem in 3 ways. The reason for this is that you want students to start thinking about how to solve a problem in a variety of ways. What would happen if I solved it this way? Now, what will happen if I solve it using this tool? Be sure that you are not only modeling how you are solving the problem, but also about the thinking process you are going through. The students will benefit from hearing how a proficient problem solver thinks about a problem. After the teacher demonstrates how to solve the problem, students have an opportunity to solve a similar problem. Most problems will include 2 questions to solve. The student solves the problem at the level of support that is most appropriate for their needs. The directions for each level do vary in support. Read through each level to see which level will be the best fit for each student in your group. It is also important to note that the levels within each lesson are fluid. If a student is more successful at one of the levels, use that level. If a student needs to try a different level, even if it is only for one lesson, that's fine as well. The choice is flexible from lesson to lesson. The levels are there to support the student, so you want to choose a level that provides the correct amount of support for each student. As a reminder, the purple words are ones that you will find in the Action Dictionary. As you read through the levels, be sure to reference the Action Dictionary to identify how to support your students accessing these particular action words. Note, the directions also state that the students can choose the manipulatives they would like to use to solve the problem. As you are reading the levels, keep in mind that if a student chooses a different tool, keep the framework of the level constant, but switch out the tool for the one they chose. If they chose a tool that will not work, it is still good practice to let them try. Then you can have a discussion about why that tool wasn't a correct choice and what a better choice could be. Here's an example of how a Level 1 student is supported with materials written into the lesson. Workmat 17 is presented to the student with the even numbers circled. 12 is written and the 2 in the ones place is circled. The vocabulary pick symbols even, and odd are shown as an increased opportunity for success. Students will use this to indicate their choice. After they make their choice, 6 pairs of socks are used to check their answer. Students pair socks and see that there are 6 equal sets with none left over, so 12 is an even number. While completing their problem-solving activity, students record their answers on problem-solving worksheets at levels 1, 2, or 3. Again, if a student needs to use an alternative method to make a choice or select their answer, you are encouraged to make that adaptation. However, allow your student the opportunity to record the answer to their problem. Again, this is an important component to solving math problems and communicating about what was learned. The second part of the problem is then repeated using the same materials and the same levels of support as outlined within the lesson. This time, the student identifies if 13 is even or odd. Level 2 supports students with pick symbol representations and math tools. In this example, the student is responsible for using the number line to identify if 2 is odd or even, then apply that to the number 12. Instead of real socks, students use pick symbols of socks to continue adding one sock to make equal sets. This is an example of a problem-solving page for Level 2. The entire problem is pick symbol supported, and both questions are listed. Students use the tools they used to solve the problem to record their solution. Level 3 pulls back support a little bit more from Level 2. Students now use more abstract representations to solve the problem. Students at Level 3 can use the number line to identify odd and even single-digit numbers and apply that concept to larger amounts. Students then add 1 and choose odd or even. This is an example of a Level 3 worksheet. Students do not have pick symbol supports, and the entire question is written on the page as well as additional challenge questions. The next part of the lesson is Prove It. Once the students have solved the problem and recorded their answers, we want students to think about proving it. Prove It focuses on explaining or demonstrating an understanding about how the student solved the problem. At Level 1, you might ask a student, "What can you tell me about odd and even numbers?" Again, thinking broadly about how a student can respond or answer this question, you may ask students, "How did you solve the problem?" A student could eye gaze or touch a tool that they used, or they could use a communication device to tell about how they solved that problem. At Level 2, students show where they got the answer and also show what helped them get to the answer. And at Level 3, students show what part proves the answer and why. They will also answer the question, "Why did you choose this to solve the problem?" This challenges students to think critically about their own problem-solving process. At the close of the lesson, there are 2 activities. First, students write or demonstrate the answer to the question on the I Learned work mats. Then they will answer the question, "What have you learned?" either in their number notes or on the group number notes poster. You will find the I Learned work mats in the members-only content. The 3 work mats are leveled, and the work mats provide a framework so students can show what they know. Now students will be able to use any materials, resources, or manipulatives to show how they solve the problem. For example, on Level 1, a student chooses the pick symbol odd, and the student uses 1 sock to represent odd. Next, the student chooses the picture symbol even, and the student can place another sock on the work mat. This is an example of what the student at Level 1 has learned. Level 2, a student chooses the pick symbol pattern to show the pattern of odd and even numbers. Then you ask the student to show it, and they show it with a group of odd and even pennies. Finally, ask them to show it with a different tool. Now a student shares the number line and circles all of the even numbers, highlighting the pattern. Now, looking at numbers 12 and 13, I know from looking at the ones place that 12 is an even number and 13 is an odd number. At Level 3, a student may write or dictate this section or a portion of this section. Students state that even numbers will have 0, 2, 4, 6, or 8 in the ones place, and odd numbers will have 1, 3, 5, 7, or 9 in the ones place, and that is a pattern. When a student is asked to show it, they show it with the numbers 0 through 9, and when looking at the 2-digit numbers 30 and 31, they use the ones place to show which number is odd and which number is even. Moving on, now students are asked to show it with a different tool, and in this example they are using 10 frames. Finally, we ask our student, how can they use this information? The student might respond by saying that they can share even amounts of candy with their best friend. When given a choice between 12 or 15 pieces of candy, students will say that they can share 12 pieces of candy evenly with their friend. In number notes, similar to the way the students talked about what they learned and similar to the ways in which they wrote about what they learned and what they saw during the discussion activity on the first page, students have an opportunity to write on the number notes page using numbers, stamps, math symbols, pick symbols, choosing and fastening objects, dictating word sentences or phrases, drawing what they have learned about, or using photos. These are all ways students can write about math. After looking at the full 2-page lesson, the question that usually follows is how long does it take to complete an entire lesson? Or how long should I spend on a section? That answer will vary from classroom to classroom. Here's an example of the suggested pacing guide that can be found in the overview manual. For students who benefit from Level 1 supports and a slower pace, or for students that need repetition before moving on, it might take the teacher 1 to 2 weeks to get through the 2-page lesson. For students who have a longer direct instruction of math or benefit from environmentalist supports, it might take an average of 1 week per lesson. For students who move at a faster pace, have an even longer instructional period, or require less support, 2 to 3 days would be a reasonable pace. Practicing concepts in a functional way is important for retention. In the members-only content, you have games and game materials that you can print. These can be found in materials and materials lists. You can also incorporate your own games or activities as well. Practice should occur after the concept has been taught, and review is always a great plan. As we conclude this webinar, I would like to thank you for your time today. The Equals Pre-Algebra and Pre-Geometry curriculum provides consistency and support as students are introduced to new math skills. If you have any questions or would like to request a live training for the Equals Math curriculum, please contact a curriculum team representative at curriculum@ablenetinc.com. We look forward to hearing from you.